sellers know price is charged by firms, right? So the firms know exactly how much they're charging, right? And the buyers know exactly what that price is. So where is that not the case? eBay, flea markets, right? Sometimes sort of bargaining situations where you bargain over the price. I was just in Istanbul last summer, and I don't like bargaining, so I didn't. So I paid a lot for stuff, but I didn't have to bargain, which I really enjoyed. But the point here is, in this market, everybody knows price is charged, and transaction costs are really low. So if you buy something, a part of the value of the good doesn't disappear in the transaction. So some of you might have bought a house before. If you buy a house, are transaction costs low? Ooh, no, they're really, really high. You pay tens of thousands of dollars in transaction costs when you buy or sell a home. The realtor gets a cut. I forget who else gets a cut. It's sort of like you stand there with a bag of money in your new front yard and say everybody have some money, right? But the point here is, housing markets are certainly not perfectly competitive because A, the product is differentiated. Each house is different than the next. Plus, transactions costs when you buy or sell a house are significant. Examples of transactions costs being low: if you go into the store and you buy a bag of M&Ms, right? You walk in, you slap $1.25 on the table, and you get a bag of M&Ms. The time used and the value of the transaction itself costs nothing. Credit cards, of course, play a thing here because credit cards transaction fees are actually not insignificant. So if these four assumptions hold here, I'm going to say that firms are price takers, meaning a firm has that residual horizontal demand curve where it cannot affect the market's price, right? So in a perfectly competitive market, an individual firm cannot affect price, and neither can a consumer. What's an example of a non-competitive market? How about the market for operating systems? Microsoft, I think Windows 10 is going to be free if I'm not mistaken, but prior to Windows 10, what did Microsoft do with its Windows products? Did it go to a competitive market and look up what prices for operating systems were that day? No, it set the price, right? $99 or whatever it is, it determines the price. So that individual firm could affect the price for the vast majority of operating systems on personal computers in the United States. Market for operating systems, not perfectly competitive, okay? Because firms aren't price takers. So here, for now, we're going to assume that firms are price takers. Again, I said that a lot. Most markets aren't perfectly competitive, but we're going to spend a lot of time on this competitive market. And the reason for that is that perfectly competitive markets are wonderful benchmarks. I'm going to show you that a perfectly competitive market maximizes a certain measure of societal well-being. It's one I'm going to make up, and we're going to have a lot of fun with, and you're really going to hate by the time midterm 2 rolls around. But it maximizes a measure of societal welfare in a way that makes society as well off as it can be. So we're going to use that as a benchmark to see how far from that ideal situation are we if we violate certain assumptions. For example, the firm that gets to set price, or a firm that gets to differentiate its product, or settings where there's not perfect information about prices or quality of vehicles. So in the short run, the competitive firm is a price taker, right? It's a price taker in the long run too, but as it changes its output, as it ramps up production or ramps down production, the price it gets per unit does not change, all right? So what this means is the revenue for an individual firm is simply the price per unit set in the market, right? It doesn't influence it, times the quantity of output it produces. So a competitive firm's revenue is price times quantity. Well, max, we've always set total revenue with price times quantity. But total revenue is price times quantity in settings where a firm influences price too, right? So what I'm saying here is price is not a function of quantity. Price is a dollar number that the firm looks up in the market and determines how many dollars can it get per unit in the market for its good, and it multiplies that by the output number it chooses to produce. So a competitive firm's total revenue is just price, the perfectly competitive market price times its output choice. This means that its marginal revenue, the change in total revenue, if it sells one more unit, is simply price. If you sell one more unit, the number of dollars you get is whatever that thing goes for in the market that day. So a perfectly competitive firm has a constant marginal revenue, which is market price. All right? So what this means in terms of optimal output quantity is that the firm that maximizes profits, if we look at the step 1 decision, is one that sets marginal cost equal to marginal revenue. Right? So if we go back to my little nice colorful exercise here, right here, marginal cost equals marginal revenue. So for the perfectly competitive firm, marginal revenue is simply the price in the market. Right? We will see that for a monopolist, for example, it's not just price in the market, but the price is going to vary depending on how much it sells. But for the perfectly competitive firm, each additional unit, it gets P dollars. So for the perfectly competitive firm, the optimal output level happens where marginal cost equals price. Right? Because its marginal revenue is price. Where are we? Here we are. Okay. So just to say it again, for any firm, optimal output is marginal revenue equals marginal cost. For the perfectly competitive firm, it's price equals marginal cost because its marginal revenue is equal to price. You ready for this? This is a pretty hardcore picture we're about to draw. I don't know if I'm ready for it. Whew. I'm going to have to draw this from memory too because I left my notes at home. But I can do it. That's what they pay me the big bucks for. Okay, so what I essentially want to do now is I want to show you in a graph that has a firm's short-run total variable cost curve, its total cost curve, and its total revenue curve in it. I want to show you how that relates to our average total, average variable, and marginal cost curve, and how that relates to the optimal quantity produced. This is going to be like, did I crack my Colonel Grievous joke here yet? No, I didn't. I did that for the grad students, right? So messy pictures for those of you who follow Star Wars. There's Grievous, right? He's got 4 lightsabers, and whenever there's a lightsaber fight, it just looks really messy. This is one of those pictures. Star Wars is coming back. I'm so excited. All right. Total variable cost. You've seen these before. They look like this, right? I'm going to zoom in a little bit because I just want to focus on the top picture, and that gives me a little more room to draw. So we can draw total costs on top of that. We know they're just the same as total variable costs, just moved up by, let's say, 2 squares here, okay? My total costs. And now I'm going to draw my total revenue. I don't know if you're ready for this. Yeah, we do this. Okay, total revenue. I'll explain to you why it looks the way it does in a second. Okay, the red curve here, this here is total revenue. So let's visit with this picture for a second. This is my total variable cost curve. I've seen this 1,000 times before, right? It's got the inverse U and then the regular U. We're in the short run here. Total cost curve is total variable cost plus fixed cost, so these are exactly 2 squares apart throughout this. It looks like they're coming further apart in the middle, but 2 lines that are flatter always look further apart than 2 lines that are steeper. So if you actually did this, you could see I'm not doing any funny business with my hand. It's actually the same distance apart. So the blue curves you've seen 1,000 times before. The red curve is new. The red curve is total revenue. And total revenue is price times quantity, right? That's a linear function with an intercept of 0, right? And a slope of p. It's mx plus b, where b is 0 and m is price. So total revenue, since I have q on the x-axis here, is just a straight line with a slope of price. So for each additional unit, I get p dollars. So depending on how high price is, this line will be either really steep if price is really high, or it'll be really flat if price is really low. Now, what do we want to do first? Let's look at profit maximization first, and then we'll draw the average variable and marginal cost curves. Now, what do we want to do, right? What the firm wants to do, it wants to maximize profits. So the firm wanting to maximize profits, meaning it wants to maximize the distance between total revenue and total cost. You want to have the highest difference between total revenue and total cost possible. And you definitely want total revenues to be bigger than total cost, because otherwise you're losing money. So let's figure this out. Right down here, let's pick this output quantity right here. Am I losing money? Well, this is total revenue. This is total cost. Total revenue much less than total cost. I'm losing money. So as I travel up here, what happens to the amount of money I'm losing? Does it become bigger or less? Less, right? I'm losing less money. I'm losing less money as I move to the right. What happens at this point right here? Break even. Profits equal 0. So what happens now? I don't know if I should get on this chair given my track record with this bench. I'm not getting on that chair. Digital technology to the rescue here. Okay, so this is the break-even point. I'm now zooming in on the top right part. Say stop when you think profit are maximized. Right there, we agree. Right then here gets closer and here profits are 0. So right here, do we agree roughly right here? Right, at that output quantity we think profits are maximized. Here, profits are 0. Let me zoom back out. This is exciting. You guys picked exactly the right spot. So you guys argued, and I fully agree with you, that at this quantity here, we've got Q star, right? Why is this? To the left of this point here, profits are negative. To the right of this point until we get to the next green dot, profits are positive, and then they're negative again. And the distance between total revenue and total cost is maximized at this point right here, Q star. Are you ready to get some insight? Yes. Well, Max said, at profit maximization, marginal revenue equals marginal cost, right? Or profits are maximized. Marginal cost is the slope of which curve on here? Actually, trick question. Either total variable cost or total cost, doesn't matter. Same thing. Let's stick with total cost. The marginal cost is the slope of the total cost curve. Marginal revenue is the slope of the total revenue curve. So if I was right, and I did not lie to you, which I almost never do, then the slope of the total cost curve and the slope of the red curve at profit maximization should be the same. Are you ready for it? This is so exciting. Let me draw you the slope because I'm a master drawer of slopes. I'm feeling better, can you tell? Okay. So this here is the slope at profit maximization. So the slope of this line is marginal cost. What does the slope of the yellow line look like compared to the slope of the red line? It's the same, right? So at that point, where my thumb and my pinky were spread all the way apart and profits were maximized, the slope of the total cost curve, namely marginal cost, is exactly equal to the slope of the red line, namely marginal revenue. So at this optimal output level, the distance between total revenue and total cost is maximized, and at that same point, marginal revenue equals marginal cost. Pretty exciting. This means Max did not lie to me. Who here wants to draw this picture again? Exactly nobody. Will you ever have to draw this picture again? No. Are you happy about that? Are you going to have to draw a picture that's way worse? Yes. All right. So that's why I have this other thing down here. See this one? Yeah, you forgot about that one. Okay, this is going to be my marginal cost, average variable cost. I'm going to ignore average total cost for a second. And quantity. Whew. Are you ready? Okay, so I'm going to draw my average variable cost and my marginal cost curve. I'm going to ignore average total cost for now because I don't really need it, but we'll add it in the very end for completeness. All right? So, marginal cost, we know, goes from decreasing to increasing at this inflection point of the total cost curve. Right? Average variable cost reach its minimum. That's terrible. Try that again. Average variable cost reach its minimum where the line from the origin is tangent to the total variable cost curve. Right here. So really all I need to draw my picture now is my average variable cost goes from decreasing to increasing here. My marginal cost goes from decreasing to increasing right here, cuts average variable cost at its minimum, and then starts increasing. Okay. I'll let you finish drawing this for a second and catch your breath. This was so easy, you're positively surprised. But here we're going. Ready? I knew all this, Max, but you're about to put it all together for me, like when Neo saw the Matrix for the very first time and didn't know what was happening to him, right? So what do we know? We know the profit maximizing quantity is Q star. So let's draw Q star. Let's just extend that beautiful line down into my other graph right here. Right? I know that this is the optimal output quantity right here, Q star. That's what the firm should produce. Can you tell me what price is from this picture in this market? Well, it's P, Max. I know that, right? But in the bottom picture, now that you know what the optimal output quantity is, where would you figure out what price this firm actually faces in the market? What's the competitive firm's output decision? Something equals marginal cost. Choose quantity where price equals marginal cost, right? So we know what quantity is, so pick the quantity where price equals marginal cost. So at this quantity, what's marginal cost? This one right here. So the market price this firm faces is this price right here. I need a new color. I don't have a new color, so we're going to stick with an old one, green. This here is P star. Okay? I'm going to add one more thing, and then we're going to put it all together, and then we're going to play with it, okay? One thing I asked you last time to take on faith is the profit curve. I asked you to do the same thing at the beginning of this class. but I can actually figure out what the profit curve looks like from this picture, right? Profit here is simply the distance between the red line and the blue line, which is here negative. As we go across, it goes to 0, goes positive, increasing, positive, decreasing, and goes negative again. So if I wanted to draw the profit curve, I simply draw my profit curve as follows. It's negative, goes to 0 right here, reaches its maximum right here, and goes negative again right here. Total revenue minus total cost, right? And the profit maximizing point is this one right here. Whoa, I know there's a lot going on in this picture. But when you go home and you download the PDF and you print this one out, actually you guys can't print out my drawn, do you want my drawn PDFs too? Would that be good? Okay, I'll do that. So after lecture, I'll upload the PDFs I drew that day, so you can print those if you want. But I've got everything in this picture now. I've got total cost, total variable cost, total revenue. I've got my profit curve, I've got my average variable cost, I've got my marginal cost, and I finally figured out how much that firm wants to produce at a given price. Now, this is the only time you're going to have to draw this crazy, crazy picture. What I want you to do is actually draw this slightly differently. We're going to practice this right now. So the top picture you will never draw again. The bottom picture you will draw a million times. Okay? But I needed you to see where the bottom picture comes from by using this top picture. Okay. So let's think about this. And we're approaching a big moment in this course. We're going to revisit the short-run shutdown decision for a second and tie it to this picture I just drew. So we know that the firm shuts down if revenue is less than variable cost. Right? So if revenue is less than variable cost, the firm shuts down because its revenue doesn't even pay for all of labor. So it just shuts down and pays its capital bill. In the long run, this is the same thing as saying profit is less than 0. So in the short run, if revenue is less than variable cost, I can take this equation right here, and I can divide both sides by Q. Okay? What? Max. Of course, that's true. Never. Right? Revenue divided by quantity is less than variable cost divided by quantity. Or you could think of revenue as price times quantity over quantity less than what's variable cost divided by quantity? Average variable cost, right? This cancels out. So this thing, revenue less than variable cost, simply translates into the firm shuts down in the short run if price is less than average variable cost. Right? Multiply both sides times Q, and you get total revenue is less than total variable cost, which was the short run shutdown decision. We just divide both sides by Q, and I don't have to draw that pesky top picture. I can just draw the bottom picture. If price is greater than average variable cost, the firm produces Q star, an output level, wherever price equals marginal cost. Hold on, Max. What have you just done? I've done something amazing. I have taken my shutdown and my optimal output decision, and I put them on one slide, and I'm about to put them to work, because I can now figure out what's optimal for the firm. The firm should always produce an output level such that price equals marginal cost, right? That's the optimal output level, unless price is less than average variable cost. Now let's look at this graphically, right? In words, this sort of makes sense, but in a graph, this is going to make your head explode. I hope it won't, but it could, because it's so amazing. Okay, so the firm's short run, competitive supply curve. Hold on a second, Max. You're using the S word here. Supply curve, you're absolutely right, okay? Marginal cost and average variable cost on the y-axis, quantity on the x-axis. So I'm going to draw my favorite firm's average variable cost curve, and then I'm going to draw my favorite firm's marginal cost curve. Okay, just a stylized marginal and average variable cost curve like you draw on any Tuesday morning. So what I want to figure out is, on this picture, where does the firm produce and where doesn't it produce? So let's take a vote, okay? I'm going to propose some prices, and you're going to tell me what the firm's optimal output level is, okay? So P1, at P1, if that's the price the firm faces, the firm simply goes across and looks at P1, what is marginal cost at P1, and figures out the quantity, right? So this is the firm's profit maximizing output level at price is P1. Should the firm produce or shut down? Who here thinks the firm should produce? Who here thinks the firm should shut down? And the rest of you just are waiting for the answer. So I congratulate you who raised your arms in the beginning. Why should this firm produce? Because price here, P1, at that output level, is greater than average variable cost at that output level, right? So price is above average variable cost. The firm should produce P1 and can go ahead producing. How about P2? Oh, no, not again. What did we do last time? We waited for 5 seconds and then it came back, right? I don't think it's going to come back. Okay. Wow, so this is where the artistry is going to impress you. Are you ready for this? Okay. I'm a little nervous. That's a beautiful average variable cost curve. Okay. 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 So that's the marginal cost curve. Now let's draw a second price. How about this one? P2. Well, the firm produces Q2 units. Should the firm produce? Well, yes, sir, because price right here, P2, is above average variable cost at that output level. The firm should produce. What about P0?